Now let's move on to Bucket Brigade. Okay, so in this problem, a fire has broken out on the farm and the cows are rushing to try and put it out. The farm is described by a 10 by 10 grid of characters. Okay, the character B represents the barn, which is called fire, L is the lake, and R represents a large rock. The cows want to form a bucket brigade by placing themselves along a path between the lake and the barn so they can pass a bucket of water along the path to help extinguish the fire. A bucket can move between cows if they are immediately adjacent in north, south, east, or west. The same is true for a cow next to the lake. The cow can only extract a bucket of water from the lake if she is immediately adjacent to the lake. Similarly, a cow can only throw a bucket of water onto the barn if she is immediately adjacent to the barn. So they can't be diagonal to something. They have to be either north, south, east, or west of it. Please help determine the minimum number of empty squares that should be occupied by cows to form a successful bucket brigade. A cow cannot be placed on the square containing the large rock, and the barn and the lake are guaranteed to not be immediately adjacent to each other. Okay, so this seems pretty straightforward. So if there's a barn in one position, a rock here, and a lake, there'll always be some sort of L-like way to go here. It can be like that. And that's always optimal because you can only move north, south, east, or west. So this is the most optimal way. And so to go from the lake to the barn, so it'll be the other way around actually, but it'll be this way. To go to the lake to the barn in this example, you would need 3 steps left, and then 1, 2, 3, and then 1, 2, 3, 4, 5, and then 6 steps up. And that is always the optimal way to do it if we have this L-like structure. It doesn't even matter if the rock blocks it, because it'll still take 6 up and 3 left. But here it'll be 6 up this way, and then 3 left this way. So the overall change would always be 3 left and 6 up. So I mean, if there was a L here, so this is still a L-like shape to go from the lake to the barn. And the rock doesn't play any impact here whatsoever, because in this case also, if the rock was placed right here, we could just go around the rock like that. So as long as the lake and the brick aren't on the same line, the lake and the barn aren't on the same line, we are fine. The only case where the rock is an issue is if the lake and the barn are on the same line. If there's a rock here, now we have to go around the rock. And this will add an extra 2 to the answer. So essentially, we can just calculate the answer by looking at the Manhattan distance, I think, between the barn and the lake. So if the lake is what? Just call it x for the lake, and then y for the lake, and then we have x for the barn and y for the barn. We just need the absolute value of xl minus xb plus yl minus yb, and that tells us the minimum distance it takes us to go from the lake to the barn if we have this L shape. Now in the case where there is no L shape like here, and it's a straight line and the rock does block, if the rock does block, then the answer is going to be this plus 2, because we have an extra 2 steps to go around this rock. But if there's no rock at all, and the rock's somewhere down here, then we can just go in a straight line, which is the same thing as the Manhattan distance. So we can always calculate this, and then we check if the barn and the lake are in a straight line, and if the rock blocks. And if that's the case, we add 2 to it. And I think that should be it. So what's our input? It's just a 10 by 10 and we output the minimum distance. Okay, not bad. So we just make a character grid of size 10 by 10. And then same thing for J and 10. We'll see in grid IJ. So along the J, yes, the I would be the rows, this would be the columns. Yeah, and this is, so we'd read in everything. And the first thing we do is we want to keep track of where the barn is. So we need, the barn would have an X and a Y. So we just make it a pair. So pair int, we'll have a barn, a lake, and a rock. Right? And so we can actually do it here. So let's just make this nicer. Now we close this. If where we currently are at is the lake, now we'll want lake dot first equals actually, is there any need for that? No, we can just say lake equals ij, and now we can do the same thing with rock and barn. Rock equals ij, barn equals ij. So now we've read in the input and we know where the barn, the rock, and the lake are. So to calculate the Manhattan distance, that is going to be the absolute value of barn.i minus lake.i, plus the absolute value of barn.j minus lake. Oh no, it's first and second, because these are pairs, and this is how you take the first element of a pair, and this is the second element of the pair. So this is I and j. Do we now have the Manhattan distance? Now, before we output the answer, we have to check if the barn and the lake are in a straight line. So that is either if they have the same x coordinate or the same y coordinate. So if barn dot first equals lake dot first, or barn dot second equals lake dot second, then we know it's on a same line. If it's on the same line, we have to check if the rock is also on the same line. And the only way the barn, the rock, and the lake will be on the same line, so like if the barn was here, for example, would be if they all shared the same x coordinate or the y coordinate. Here, they'd all share the same y, because they'll all be on the same column. So now how do we deal with that? So this is not the case. We can just see out the Manhattan distance. Now we check. Actually, yeah, we can do this in one check, I believe. We can check. And and should be here. Barn dot first equals rock dot first. Now we do the exact same logic, but for second. We do this. Oh, whoops. Just I'll call second here. So what this does is we check if barn dot first is if the barn and the lake are on the same row, and this checks if the barn and the rock are on the same row. If that's the case, all three are in the same row, which means we have to go around the rock. Aha, but there is a case where that doesn't matter. So if they're all on the same row here, of course we'd have to go around the rock, right? But if they're all in the same row and the rock does not interfere, then we're fine. Interesting. Okay, so I don't want to make this a super complex or and all that, so now we just add an else if. So this is check same row, this is check same column. So now we want to check if the rock intercepts the barn. So the way you do that would be another. Okay, we don't need this additional one anymore. And rock dot first is less than the minimum of barn dot first and lake dot first, and rock dot first is bigger than the maximum of barn dot first and lake dot first. So this ensures that the row, since we know that they're in the whoopsie, second here. Second. Okay. So what this does is we say, hey, is the barn and the lake in the same row? Yes. Is the barn and the rock in the same row? Yes. Then all three are on the exact same row. Now we want to check if the rock interferes between the walk from the lake to the barn. And so now we look at the y coordinate and we say, okay, since you're all in the same row, it looks something along the lines of barn, rock, lake. Now we say, okay, we now know we're on the same row. Now let's look at the y coordinate and see, hey, is the rock in between the barn and the lake? So we say, okay, is the y coordinate of the rock smaller than the minimum of the barn and the lake, and is it bigger than the maximum of the barn and the lake? If that is the case, we are good to go. I think adding brackets here would make the code better. And if that's the case, we just see out md plus 2. Now we can use this exact same logic for the columns, but one small change. And that change is now we don't check if we're in the same row, we check if we're in the same column. So this is going to be second. And now that if we're on the same column, we have to check that we have to check the rows. So this should be first. So here we check if the barn and the lake and the rock are in the same column. If they are, it would look something like this. Now we say, okay, now we go row by row and we see if the row of the rock is in between the barn and the lake, where in this example over here, it is not. And if that's, but if it is indeed the case, we see out md plus 2. Oh yeah, whoops. Cannot comment the. The answer received is Okay, let's see where we went wrong. Let's debug lake, rock, and barn. Lake is 1, 2, 3, 4, 5, 6, 7, 8. Oh, it starts at 0, so yeah. 8 and then 0, 1, 2, 3, 4, 5. Yep, 8, 5. This is going to be 8, 7, 6, 5, 5 for the rock. And the barn is going to be 3, 2. Yep, that looks good. Distance wise, if you just look at the Manhattan distance between the lake and the barn, it's going to be 5 plus 3, which is 8, but we want 7. Why is that? Because we go 1, 2, 3, 4, 5, 6, 7. There's an extra 1 here. So the answer that we should actually keep is this minus 1. Because essentially, yeah, right, because if there's something lake to barn, the Manhattan distance would be 1, 2, 3, so it would be 1, 2, 3, 4, but we only need 1, 2, 3 cows. Yep. So it would be v1 minus 1 of the Manhattan distance. Okay, good. That is correct. And now let's check the case. Here it should be 1, 2. Okay, it'd be 1, 2, 3, 4, 5, 6. Answer should be 6. Is that expected? Answer is 4. Ooh. Okay, let me do one thing first. Let's put the rock a bit to the side. What's the answer now? 4. Aha, this is 4. So it's 1, 2, 3, 4. But this should not be 4 because there's a rock in between. So same, we're here, okay? So let's see this. If barn dot second, yeah, barn dot second equals lake dot second, and lake dot second, yep, they all have the same y. If rock dot first, it should be bigger than the min and less than the max. It should be bigger than the min and less than the max. Okay, now it should be 8. Or 6. Yeah, it'd be 4 plus 2. Okay, that is correct. Yeah. It's always good to check your signs. Always good to check your signs. Now, what is the IO? The name is called buckets. And this should be good to go. Oh yeah, that's fine. Oh, whoops, let me just log in quickly. Okay. Oh, I solved this before. But I think it should be fine. Where are we? CP, record. Nope, not recordings. Code. Where are we? USACO, general. What is this one called? Bucket Brigade. Open. And voila.